Thank you so much for allowing me to present my work here. My name is Chee Keong Wee. I'm a data engineer with working at eHealth Queensland. And together with my son Nathan, we like to present our works on outlier detection for medical referrals in the Otorhinolaryngology today. It's a project that was assigned to me by my director, which is we work in the clinical business intelligence groups there. So this is the works that we present. It's one of the three papers that we have, or three works that we present. And this one is in regards of the outlier detections for the medical referrals. The triaging itself, right, is a process, right, usually performed by the clinician to prioritize and allocate treatments to patient based on the system that to maximize their survival and recovery. But the triaging is usually performed by clinicians, right, before being assigned to the specialist, and it is usually very time-consuming and require a lot of expertise like that. But we need to have a way, right, to gain insight on past and present triage referral, just in case, and see what are the benefits that we can ever get there. So the motivations, more or less, for this paper is to find the anomalous triage referrals that doesn't really fit into the anomalous triage groups that we have. We try to gain more insight to the past and present triage groups there. And once we have identified the anomalous or those that do not fit the common triage group, right, we can able to forward to the clinicians, right, to have a closer look at, and this helps to improve the overall triaging processes. Well, the data set that we have, right, it's part of the smart referrals that we had in Queensland Department of Health. It's a subset of from the system that we had called the smart referrals. So the system that the data set that I worked on, right, comprised of three categories, with one being the highest and three being the lowest. There's altogether about 3,000 of them. It's a 100 group, and we do not make any distinctions in the sub-body parts. So this is the current layout that we have for the GP referrals in PDF formats, very converted the text conversions. And then we subject it to a medical NLP to extract out knowing the medical terms, right? But the ICD codes and it's not there. Then we will transform them into a characterizer. We use the dimension reductions using the UX algorithms. And further, then we use the OLF algorithm to identify. Then we can able to identify the outliers itself. So I understand the nature of this. We are using one of the AWS Companion Medical Cloud services, because we can't find any other replacements for that. So what it does, like, you can able to pass the unstructured medical text itself, right, and to identify the personal hidden identifier, the medical terms, and the medications that are written in the medical referrals, right? Then you can have the ontologies to link up to the ICD codes, right, where we should be able to extract it out eventually. So there's a process basically to do the features extractions and preparations, right? From the PDF formats, unstructured text, we extract out all the medical terms. RX codes and ICD codes has been identified with the highest score. We format as the string and arrays, right, and the labels. Then we make it into the count vectors. So we use two algorithms, and one is to reduce the dimensions, and the other one is to use it to identify the outliers. So this is the result that we have, right? As you can see from all these three categories, there's a few outliers or unique positions of the points that has been doesn't fit with the normal distributions there. So we can able to identify this and extract out the medical terms, right, in an array form there. Then from there we can able to reverse engineer and look up the actual referral IDs, right, and then we can able to forward to the clinician for further investigations. This is the list of all the medical codes, right, that has been identified in the outliers of referrals. So in conclusion, right, this is more or less we can able to achieve a great accuracy. We have more data sets, which I will request from the smart referral teams there. And we can able to gather more insight further, right? And help the clinicians trying to fine-tune or improve their triaging process. And we plan to extend the triaging process to other areas like medical imaging. And at this point in time, we managed to win about, my director managed to acquire about $700,000 in innovation funding from the state government. Well, I thank you for the time to listen to me, and